Welcome to another Algebra 1 lesson. I'm Mr. Pilarski, your teacher this year, and this is Unit 1, Lesson Topic 3. We're working out of Pearson Algebra 1, and this is Section 2.1 from that textbook, copyright 2009, adding rational numbers. Now, this is Part 1 of Lesson Topic 3 from our curriculum. Our objectives today are I will be able to add rational numbers using models and rules. The second objective, I will be able to apply addition. Important vocab for today, the identity property of addition, the additive inverse, the inverse property of addition, matrix and element. Let's get this math party started. Here we're going to start talking about adding rational numbers, and something that you should know from, when you're younger is the identity property of addition. Now that identity property of addition basically says that anything plus 0 is that anything. Here, very algebraically, it says for every real number n, where n is any real number, n plus 0 is equal to n. Whatever you start with plus 0 is equal to with whatever you start with. And the same goes for the inverse of that, or the switcheroo there. 0 plus n is equal to n. 0 plus what you start with is equal to what you start with. Now that property is taken from Prentice Hall, copyright 2009, Algebra 1, page 56. On your handout, you can ignore this stuff below. That's actually put there a little early. So remember, the identity property of addition says anything plus 0 is that anything. Adding rational numbers, just a little bit more. The opposite of a number is its additive inverse. One of the things I look for is that you're writing these things down in your notes. Now, additive inverses are the same number part but with opposite signs. For example, if we had 4 and negative 4 and we plotted those on a number line, they are the same distance from 0. They are both 4 units away from 0. And what the inverse property of addition says that if we add two additive inverses, or additive inverses of each other, then the sum will always be 0. And that's a property right here, the inverse property of addition. For every real number n, there is an additive inverse, the opposite of n, such that n plus the opposite of n is equal to 0. Our two numerical examples here, 17 plus negative 17 is equal to 0. And if we switch that around, negative 17 plus 17 is equal to 0. So that's going to be the additive inverse, especially useful whenever we're solving equations a little later this year. Here in example 1t, we're using a number line to model the addition of rational numbers. More so, we're using them to model integers more exactly, but integers are rational numbers. Now, example A says 3 plus a negative 5. And to do that, what we do, it's 3 basic steps. You don't necessarily need to write them down, but you do need to know that you're going to start at the first number, and the first number here is 3. So I'm just going to put a little dot there. And then it tells me to go negative 5, plus negative 5. Well, negative 5 would be 5 to the left, so we'd go 1, 2, 3, 4, 5. And 3 plus negative 5 gives us a negative 2. So the answer here is a negative 2. So we start at the first number and then we go left or right depending on what the sign of the second number is. Now in example B, we have negative 3 plus 5. So our starting point in this case is negative 3. That's where we'll start at. And then we have to add to that 5. So adding to that to the 5 means we go to the right 5. 1, 2, 3, 4, 5. And we end up at a positive 2. So the answer here is 2. And it's really, and we're going to learn rules about this in a minute, but whatever number has a greater absolute value, that's going to be the sign of the answer. Now here's a case where we have two negative numbers, and our starting point is 3, and we have to add to that negative 5. Well, adding negative 5 means we're going to go to the left 5. 1, 2, 3, 4, 5. And our ending point is negative 8. So the answer to negative 3 plus negative 5 is negative 8. What I do want to summarize is that this takes 3 steps. You have your starting point. You decide whether you go left or right depending on what number's being added. then you make that move, then you have your ending point, which is the answer. There are two rules when it comes to adding rational numbers that we need to concern ourselves with. The first rule is here, and it's adding numbers with the same sign, and meaning that they are both positive or they are both negative. And it tells us to add two numbers with the same sign, add their absolute values. The sum has the same sign as the add-ins. So here in this case, we're adding numbers with the same sign, so we add their absolute values. If both of the add-ins are positive, then the answer is positive, and both of the add-ins are negative, the answer is negative. You might even want to write this down above it. We could say here that a positive plus a positive is equal to a positive, and a negative plus a negative, the answer is equal to a negative. The second rule that we need to concern ourselves with is this rule down here, and if you don't have a highlighter, you can underline what I'm highlighting, adding numbers with different signs. Now, this is a review from pre-algebra. You learned how to do this in pre-algebra, and I kind of expect that you should know how to do this, but if you don't or you forget, here's a good reminder. What this says here is to add numbers with different signs, find the difference of their absolute values. The sum has the same sign as the add-in with the greater absolute value. So we need to find the difference if they have the same sign. And that's to find the difference of the absolute values. In this case, to add numbers with different signs, we actually subtract. That word difference means we need to subtract. And you can see down here that if you have a negative plus a positive, the answer is positive. And in this case, you have a positive plus a negative, the answer is negative, because negative 6 has a greater absolute value than 2. Here, positive 6 has a greater absolute value than negative 2, so the answer is positive. So when you're adding numbers with opposite signs, the answer really depends on which number has the greater absolute value. Let's take a look at this in some examples now. Example 2t, I'm going to model how to add some rational numbers. All the examples we've seen with the properties, we're working with mainly integers to get you to the idea used to the sign. Well, here we have some true rational numbers. We have to add two fractions. And remember, when you add two fractions, you have to find a common denominator. So we're not going to decide about the sign to our answer just yet. We're going to worry about that once we have the common denominators and we adjust the numerators. 5 and 7 are our denominators, and a common denominator, the least common denominator in this case, is 35. Now, what I'm doing is I'm going to rewrite the fractions with a new denominator and a new numerator. 4/5 is negative, so this fractional equivalent will also be negative. I have to multiply 5 by 7 to get 35. So 4 times 7 is going to give me 28, so that's negative 28 35ths. And I'm going to be adding that to 3/7 with a denominator of 35. 7 times 5 is 35. 3 times 5 is 15. So now, when I look at these numbers, negative 28 35ths has a greater absolute value than 15 35ths. Therefore, my answer is going to be negative and something over 35. I might have to reduce that answer, but we'll do that in a moment. So now I have to subtract the numerator's absolute values. I actually need to go 28, take away 15. 8 take away 5 is 3, and 2 take away 1 is 1. So the numerator here is going to be 13. So final answer when I subtract these two rational numbers is negative 13 over 35. I had to subtract their absolute values because they were opposite sign numbers. In example B, we're going to follow the first rule where we have same sign numbers. Both numbers are negative. Therefore, we're going to add the absolute values, and the sign is going to be negative since we're adding two negatives. So we have to add their absolute value, 6.4 plus 8.6. 4 plus 6 is 10, carry the 1. 8 and 6 is 14, plus 1 is 15. So our answer here, the number part is 15.0, and the sign is negative, so the final answer here would be negative 15.0. It's important to follow the rules when adding rational numbers or sign numbers by hand. Example 3t, we have a real-world problem-solving situation. You wouldn't necessarily in the real world write out an expression, but we want to see that you understand the idea of variables and expressions and this idea of adding rational numbers. In this case, we end up working just with integers. It says the water level in a lake rose 6 inches and then fell 11 inches. Write an addition statement to find the total change in water. So we're going to write an addition statement for the first sentence. It says the water level in the lake rose 6 inches. Those are key words. That's going to tell us that it went up 6 inches, or represented by a positive 6. And then it fell 11 inches, which is going to be designated or represented by a negative. And we're going to add those two things together. So taking a look at this, writing an addition statement, so we want to write a statement, an expression for rose 6 inches, plus fell 11 inches. Well, rose 6 inches is represented by positive 6. And we have to add that to fell 11 inches, which would be a negative 11. We can simplify this a little bit because we don't need that plus sign there. Ultimately, this would be 6 plus negative 11. And it is definitely proper for you to put parentheses around that negative sign to separate it from the addition sign. So this would be the addition statement that we would use to find the overall change in water level here. Here in applying addition, we're going to talk about an expression like the opposite of a variable. And here we start off with you can evaluate expressions that involve addition. The expression negative n means the opposite of n. So you can evaluate expressions that involve addition. The expression negative n means the opposite of n. And that's taken from Prentice Hall, Algebra 1, 2009, page 58. So we're going to evaluate expressions that have things like this. And this is where students do get tricked up a little bit. So let's take a look at an example. Example 4T, we're evaluating expressions. And like the last slide said, we're going to be looking at this expression right here, the opposite of t. And that's going to be a little confusing because here, t is actually given as a negative number, so when we go to substitute in negative 1.7 for this opposite of t, watch what happens. I'm going to copy down to 3.6 plus. And here, my first parenthesis, the opposite of, now for t, I need to put in the negative 1.7. Now, I know your previous year's algebra teachers, or probably previous year algebra teacher taught you that a double negative always makes a positive, and this is where kids make the mistake. Fail to realize that right here is going to give us a double negative. A lot of times it only gets put in as a single negative, but what we end up with is a double negative. And that always becomes a positive. So rewriting this a little more simply would be 3.6 plus 1.7. And adding those together, 7 plus 6 is 13. You'd carry a 1. 3 and 1 is 4, plus 1 is 5, and the decimal would go right between them to give you 5.3. Be careful when you're substituting in for the opposite of a variable or a negative variable. You need to change the sign. Really, you're going to see that in your coming examples. Here in example 5T, we have a real-world problem-solving situation. It tells us a scuba diver who is 88 feet below sea level begins to ascend to the surface. Let's break that down. See what that means. 88 feet below sea level. Well, I think as a number we would represent that as a negative 88 with the sea level being the 0. Above sea level would be positive. Now ascending means that that person is coming up towards the sea level. What we need to do in part A is write an expression to represent the diver's depth below sea level after rising any number of feet. Well, to do that, we're going to start off with negative 88, meaning 88 feet below sea level. And to that, we're going to add the number of feet ascended. And then from there, we have to pick a variable, and we can use any variable one. I'm pretty comfortable with x, so that'd be negative 88 plus x. And we could say over here where x is equal to the number of feet ascended. What we did there is we defined a variable and we have an algebraic expression. Now it says in part B, find the new depth of a scuba diver after rising 37 feet. So we simply have to understand that 37 feet in this case is x, and that would be negative 88 plus 37. And since they have opposite sign numbers, we have to figure out is the sign of the answer going to be positive or negative. And in this case, negative 88 has a greater absolute value, so the sign of the answer is going to be negative. And we subtract their absolute value. So that'd be 88 take away 37. 8 take away 7 is 1. 8 take away 3 is 5. So that'd be at negative 51 feet, or still 51 feet below sea level. Remember, according to our rubric, to receive full credit or receive the most amount of points when grading yourself on the rubric, you have to be able to define a variable and write the algebraic expression to achieve that level of at least a 3. Often we have data displayed in tables or in magazines or anywhere where we have multiple pieces of data being compared. We can use matrices to add numbers. A matrix is a rectangular arrangement of numbers in rows and columns. We can see here U.S. school enrollment in millions. We have elementary level, high school level, college level, and the public sector versus the private sector. We take that information and simply focus in on the numbers. Now we have the labels here, but we're going to focus in on the numbers. You identify the size of the matrix by the number of rows and columns. The matrix above has 3 rows and 2 columns. Each item in a matrix is called an element. And the idea, when we look into the next example, when we add 2 matrices, we're going to add them element by element, or corresponding part to corresponding part. In example 16, we're going to be adding matrices here, and that's exactly what we're told to do. So here we have to identify this matrices, their size in a way. And remember, matrices are counted by their number of rows and then their number of columns. So both of these matrices are 2 by 3. So what that means is our final answer is going to be a 2 by 3 matrix. And what I'm going to do is set it up, start to set it up, so you can see how we have to show our work to keep it organized. Now, each one of these lines represents an element in my answer matrix, and I'm going to show the work here. This is a step you may or may not have to show. I found quite success with an Algebra 2 student when he was learning about matrices to use this method here to kind of organize it. And what it has is it's going to be 2 rows by 3 columns. So what we have to do is add each one of these piece by piece. So here I have to add negative 6 to 7. And I'm going to do that right here on the upper left-hand side of this. Negative 6 plus 7. The second part of that, I'm going to add 8.6 to negative 5.4. And finally, I'm going to add 11 to negative 2. And that's my first row. That'll be my first row of answers. Now, next I'm going to do the second row. So I have to add 2.3 to 11.1. Then I have to add 5 to 3. Then I have to add negative 3 to negative 1. I add it part by part. Now I simplify the matrix. I simplify each element of the matrix. And negative 6 plus 1, or negative 6 plus 7 is 1. 8.6 plus negative 5.4. Now the answer to that is 3.2. And I had to subtract their absolute values because they were opposite sign numbers. Same here, 11 plus negative 2 is a positive 9. 11 take away 2 is 9. The absolute value of 11 is greater than the absolute value of negative 2, so the answer is positive. Hopefully some of these things you're starting to be able to do in your head. Down here in the second row, I have to add 2.3 to 11.1, and that gives us 13.4. 5 plus 3, I think the easiest calculation, that gives us 8. And negative 3 plus negative 1, that gives us negative 4. So there we added a 2 by 3 matrix to a 2 by 3 matrix to get our resultant matrix. Now, these had to be the exact same sign for us to add them together. Not sign, but size. I don't think I mentioned that yet. For us to be able to add two matrices, they have to be the same size. And these were both 2 rows by 3 columns.